Hi, in this video I'm going to discuss some of the relationships between angles on this simple relationship of parallel lines cut by a transversal. And so we could take two different approaches to this, or more than two anyway, if we really wanted to. We could measure these angles and then replicate the experiment again and again and again, and then confirm our findings that angles like these here, right, corresponding angles are equal, or vertical angles are equal. Or we could accept as true the postulates and theorems of geometry. And we would then be able to, through logic, actually prove these, that if we have a line here or a line segment and it's cut by another line where we form two angles, then these two angles here, this one here and this one here, are supplementary because the number of degrees on any line are equal to 180. And so if this angle and this angle are supplementary, then we also have another line this way, which means that this angle and this angle are supplementary. And if these two angles are supplementary, we'll call it A plus B equals 180. Then A plus this equals 180. And we already know that A plus B equals 180, so that must be true there. If we want to look at these two parallel lines like copies of one another, we replicated or copied it and then moved it up the transversal, then we know these two corresponding angles, they're called corresponding because that would be the same part of the same relationship. We just took a copy of this, moved it up, and we get the same angles because it is just a copy. If it's parallel, that means all of the angles are equal. That's kind of the definition of parallel lines. We can accept that as true. And so let's look at the relationship of B, and then we can call this, is it C? No, this is going to have to be A here. Again, more corresponding angles and then vertical angles there. And so then we also know that these interior angles are supplementary because we know that A and B, when we, again, cut any line into two angles, they're supplementary because the number of degrees on any line is 180. And so these two angles must sum to 180. If this is A and that's B, that means that these two angles inside or interior are summing to 180. That must then be B, B, this must be A. And so we can see that the exterior, opposite exterior angles are congruent or equal. We can see there's corresponding angles, vertical angles. Interior, opposite interior angles are also congruent. And then the two interior angles on the same side there are supplementary. Now if we wanted to cut this with the transversal again and call these parallel, we would find that what we have is a parallelogram where if we already showed that the two interior angle sets are supplementary, and so then we can see that the two opposite corners, each of the two sets of opposite corners of a parallelogram have equal angles. That's a fairly simple relationship there. Also, if we wanted to form a triangle using the point of intersection on the intersection of the transversals with that set of parallel lines here, well, if we call that A and we call this B, then we know this is B and this is A from vertical angles and supplementary angles. We also know this over here is A. And then let's call this one C and this one D. And so then we know that's D and that's C. We also know that we have this larger angle here is C. And we know that this is D. So C plus D, of course, is supplementary. And so what we have here is A, D, and blank equal to 180 degrees. And so we're looking for this angle here. We'll call this equal, we're going to call this 2. And so we know that this is true, we can indicate our relationships or our equalities a couple different ways. We're going to call this 3. We know this is 3. And so we have A, 1 here, and we're missing a blank part. So we know that this is 2, D is 3, and so we know that A plus whatever's in the middle here, we'll call this E, A plus E plus D equal 180 degrees, and that's how we can prove that there are 180 degrees in the sum of the triangle, just like we could have a moment ago proven the same in a parallelogram, that if we have supplementary angles interior, these two are supplementary, then we have 360 degrees inside the parallelogram, 180 inside the triangle. And so by just accepting a couple of base rules and then working with logic, we can come up with independently some of these other facts in geometry. And then we could apply this to 5-sided figure, 6-sided figure, and what we end up with is 3 minus 2 times 180. Or x minus number of sides minus 2 times 180 equals number of degrees in any shape, in any regular many-sided shape, right? And so again, using just some simple formatting with geometry, we can come up with many different proofs and evidence of these different postulates and theorems by ourselves. Thank you.